Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers to sign you in. Without further ado, I'll pass it on to our presenters so that we may begin.
Good morning, everyone, and thank you for joining us again for the Friday Happy Math Hour. It's always happy to see students visit us. Again, we're on our second week, so we're practically well into the semester. So today we are planning to cover evaluating combinations of functions and composite functions. So let's go ahead and get started. So let's look at this first example. So here we have a function, f of x, which is the square root of 3x minus 2, and it's asking us to evaluate the following. Um, so again, we're evaluating a function. So the way a function works is we have an input, which is our x values, and we are trying to solve for our outputs, which are our y values. So here on A, B, and C, they're giving us the inputs, the x values. So let's look at the first one, A, x equals 2. So what that means is that for this function, everywhere we see x, we're going to plug in 2. So we have 3 times 2 minus 2. So we do the order of operations. We'll do the multiplication. 3 times 2 is 6. 6 minus 2 will give us the square root of 4. And the square root of 4, we all know that it's 2. So that's how we will be evaluating functions. Let's go ahead and look at B. Um, B, we want to replace x with a. So everywhere we see x in the function, we're going to replace the a value. So here, again, don't get scared. It's just a letter. It's not a number, but that's how functions work. We're going to plug in an input. In our input now, it's a letter. So we'll do the order of operations again. 3 times a is just going to give us 3a minus 2, and it's already simplified. We cannot do anything else with it, so that's going to be our answer. Our answer is going to be precisely this, just the square root of 3a minus 2, and that's what you would input on the computer, okay? All right, and the last one, C. Let's evaluate the function for 6 plus h. So that means that everywhere we see x, we're going to plug in 6 plus h. So we have the square root of 3 times 6 plus h minus 2. Again, we'll do order of operations. We're going to distribute that 3 to the 6 and the h, which is going to give us 18 plus h minus 2. We combine our like terms. The 18 minus 2 will be 16. And again, we cannot simplify it any further. Did you have anybody has any questions? Yeah, you're welcome to chime in or put it on the chat. If anybody has any questions, raise your hand and we'll answer any questions you may have. Okay. All right. So let's go ahead and evaluate another function. Now this one looks a little bit different, but it works the same. This is what's called a piecewise function. And I like that name because this function is made out of two pieces. You see that we have a function minus 2x minus 2 and another function here, x squared plus 2x minus 1. So we have two functions, but the way we're going to evaluate this is not that we're going to get two answers, okay? This piecewise function has a restriction on the x values that we're going to put in. Again, a restriction on our domain. And so instance for the first function here from our piecewise function, we only want to accept values that are smaller than -1. And for the second function here that we want to accept values that are greater than or equal to -1. So we're only going to get one answer for piecewise functions. We may have two or three functions in pieces of a piecewise function, but we're always only going to get one answer, okay? Because it depends on our restriction that we want for our domain, or again, for our x values. So let's look at A. A is evaluate the function at -4. So that means that my input is -4. So then when I go and I look at my restrictions, is -4 greater than or equal to -1? No, I cannot apply the -4 to this second function. But Is negative 4 smaller than negative 1? The answer is yes. So that's the function that I'm going to apply this negative 4 into this first one here. So to evaluate, I'm going to evaluate it for this one, minus 2x minus 2. And again, just like before, I'm gonna place in the negative 4 everywhere I see x. So we have negative 2 times the negative 4. A negative times a negative is a positive. 2 times 4 is 8 minus 2. 8 minus 2 is 6. Again, so the y value or the output for negative 4 is 6. Let's go ahead and do B. And again, we're going to do the same process. We say to ourselves, is negative 1 smaller than negative 1? No, they're equal, so I cannot use that first one. But is negative 1 greater than or equal to negative 1? The answer is yes. So that means that this one is only going to apply to the second function, to the x to the second plus 2x minus 1. So again, everywhere that I see x, I'm going to plug in a negative 1 to evaluate the function, and I'm going to get 1 minus 2 minus 1. 1 minus 2 is a negative 1. A negative 1 with a negative 1 is a negative 2. So my output, only 1, is negative 2 when my input, x, was negative 1. All right, let's look at the last one, C, f of 1. So here we see that it applies to the second one. 1 is greater than or equal to negative 1. So again, this 1 will apply again to the second function only, to the x to the second plus 2x minus 1. Again, everywhere we see x, we're just going to plug in 1, and that's going to give us a value of 2. Okay. Now again, if I'm going too fast, if you have any questions, please feel free to raise your hand, ask us, put it on the chat, and we will answer it. Okay. So I'm going to move forward. All right. So now let's review domain. So I did a little brief mention of domain right now when I was evaluating functions, but let's look at it closely. So the domain of a function refers to all the x values being used. Um, so again, if I see here, I have a graph of a line, right? This line has arrows on the left and right side of it. So this means that this line is going forever to the left and it's going forever to the right. So if I were to say, what is the domain of this graph? Well, it's all real numbers, right? This graph is going forever to the left and forever to the right. So again, the domain of the function has to deal with all the x values that it can contain. So on this question, does the question have a fraction that has a variable as a divisor? So no. So since it doesn't have a fraction, there's no restrictions. So then this is going to have um, a domain. Yes? All right, so another question that you want to ask when you are reviewing to see if a function has a domain, you want to say to yourself, does the function have a square root in it? And as we all know, square roots are only values that we can have positive values. We cannot evaluate negative square roots, or at least not at this time, right? But so that one will also have a restriction on the domain. So if you see square roots, then yes, it'll have a restriction on the domain. If it doesn't, then it's not. Okay? All right, and the third one that might have restrictions on our domain are logarithms. And again, on this one, you may be familiar with them, but we will be dealing with a section of logarithms in the near future, chapter 3. But if you do have a log, then it will also have a restriction, okay, on these. And we won't get into much detail because we will see them in full detail. But just as before, as I had mentioned to you, like on my line, since my line went forever to the left and forever to the right, then the domain is all real numbers. And the way we represent that in interval notation is from negative infinity to positive infinity. The graph is, we always read graphs from left to right. So it's all of the values to the left and all the values to the right of 0. Okay. All right, so let's look at some examples to find the domain of each of the equations below. So let's start with A. Now, hopefully by now we all recognize that A is a line. It's an equation of a line because I see it as in slope-intercept form. It has my slope of 1, it has a y-intercept of 5, and since it has a slope and it has a y-intercept, it has no fractions, it has no radicals. I don't see the word log on there. So then this has no restrictions. So A has a domain, and the domain for A would be, again, I'm getting ahead of myself. I'm answering all the questions before I put them on there for you. But if you see A has none of these, so then it has no restrictions. So the answer for the domain is all real values for x. So again, an interval notation is from negative infinity to positive infinity. Now also keep in mind, also for your computer work, the parentheses means that we're not including the number. Now infinity is not a number, so that's why we'll always use parentheses when using the infinity symbol. Do not put a bracket, because a bracket means that you want to include that number, and again the computer will mark it wrong for you. Okay, so the parentheses, always put a parenthesis symbol when dealing with the infinity in interval notation. All right, so again, this was the graph of A. All right, let's look at B. So B, we have x to the second plus 2x minus 4. So um, again, on this one, my domain, if I were to graph it, you would see that it's like this U shape. Again, this U shape is called a parabola. And again, we will be dealing with this shape very soon. So, and you'll be able to recognize that comes from a quadratic. But for right now, this is a parabola looking shape. And again, I see that my arrows are going forever to the left and forever to the right. Again, I don't see any fractions. I don't see any um, radicals, square roots, excuse me. So um, there is no restrictions. So this is my domain, all real numbers from negative infinity to positive infinity. Okay. Um, but what about these two? Oh, now we have a fraction, right? So if you see on A, we have a fraction. So again, what do we never want to see as a denominator on a fraction? Well, zero, right? If we would to divide zero, thank you, Ms. Chuka, for putting that arrow, right? If we would put zero here, we would get an undefined or an error on a calculator. So that's just going to give us a restriction. We cannot use zero. So how do we represent that? Um, in interval notation, again, if x is equal to 0, this is going to create a restriction. So um, our domain is all real numbers except 0. So the way we are going to write this in interval notation is, you see there's two parts of it. It's all the numbers to the left of 0 and all the numbers to the right of 0. So there's two parts. So the way we represent that in interval notation, let's look at the left side part first. It's from negative infinity to 0. And again, we're going to use a parentheses because we don't want to use 0. If we use 0, we're going to get an error. And then we have the symbol, this like U looking shape. This means and or union. Okay, so we have two sets. We have the left and the right, and we continue. We continue where we left off. We start at 0, again, not including 0, and all the way up to positive infinity. So this is the domain of this equation right here, A. All real numbers except for 0, and that's in English. All right, what about B? Oh, B, we have also a fraction. And so we never want the denominator to be equal to 0. So if you don't see it, we can do a little bit of algebra. We set x minus 6 equal to 0, and we find out when will the x value give us 0. And we see that if x is equal to 6, 6 minus 6 will give me 0. So 6 is my restriction. I cannot use 6 for this equation. So my domain would be all real numbers except 6. So just the same way as before, I have two parts. I have the numbers to the left of 6, and I have the numbers to the right of 6 that I can use. So the domain for B would be from negative infinity to 6, not including 6, union or and from 6 to infinity. Okay, so this is how we look at domain. Domain has to deal with all the x values that the graph can have. And if we were to graph this, you would see, okay, again, this graph has a break, right? This is a line that we're going to also visit very, very shortly. It's called an asymptote, where my graph cannot cross or touch this imaginary line here at 0. Same with B. I have an imaginary line here, um, which should be at 6 here. So it's on the wrong side. All right, so let's look at these two other examples. Uh-oh, we have square roots. So again, these two examples will have restrictions. So let's look at A. Again, when we're dealing with a square root or a radicand, we want values greater than or equal to 0. We cannot use negative numbers, okay, because that produces imaginaries. But again, we will get to that in the near future. So um, all of our vex values for our domain have to be greater than or equal to 0. So how do we represent this in interval notation? So the way we're going to write this is, again, we can use 0. So now we change the syntax. Now we can use a bracket. Bracket means that I can include that number. Okay, so I can include from 0 and all of the positive numbers. So it's 0 comma infinity. Again, the infinity symbol will always have a parentheses because infinity is not a number. It never ends. It just continues going and going, going. All right, let's look at B. Y is equal to the square root of x plus 5. Well, the way I do this is I first see the 0, right? Because square roots have to, their domain is always values greater than or equal to 0. So then I start with its threshold. When will I get 0 in the square root? And I see, if I solve for it, I see that if x would be equal to negative 5 plus 5 is 0. I can put in negative 5. Now, if you don't see it, like for instance, I have the answer down for you, but the way you would do this, if you don't see it, is you would test the number to the left and to the right of it to see if it gave you a true solution. So for instance, if I say, okay, I know negative 5 gives me 0, but can I use the numbers to the left of negative 5? Well, let's pick a number to the left of negative 5. A number to the left of negative 5 would be negative 6. And if I would use negative 6 for x, I would have negative 6 plus 5. It's going to give me a negative 1. And again, the square root of negative 1 would give me an error. So that means that if I use any numbers to the left of that, I cannot use. It would give me errors. But if I use any numbers to the left of negative 5, and if I use an example, negative 4, if I plug in negative 4 for x, negative 4 plus 5 would be 1. Square root of 1 is 1. So that I can use. So it's all of the values to the right of negative 5. So my domain would be bracket negative 5 because I can use negative 5, and it would be all the numbers to the right of that. So it's to infinity forever to the right. Okay. All right. Let's look at, these are the graphs just so you can see what we're looking at here. So the first one, and we see this is the graph. It's all these values to the right of 0, right? And if we look at this other example, thank you, Yvette, it's all the values to the negative 5, right? So it goes forever to the right. So excellent. And graphs are always helpful for us to see these domains. It helps us justify or make sure that we did our algebra correctly. Okay. All right. So now let's look at evaluating functions graphically. Okay. All right. So let's look at this example. This is a little weird example, right? It looks kind of like a big W, but let's dissect it a little bit. Okay. If you notice here on um, this graph on the left side has an open circle, and on the right it has a filled circle. So open circle means that I'm starting at that point, but I'm not including 5 there. If I said y is equal to 5, I'm starting there, but I'm not including it. But on the right side, because it is filled, that means it's including it. Okay, so that's how we'll evaluate. So, but to evaluate graphs of functions, it's very, very easy. So let's look at them. Let's look at A first. The function at input x equals negative 1. So um, first, again, to review this function, its domain and range, if I see here, the domain of this function, the x values are from negative 2 to positive 2, okay? And again, as I mentioned to you, because I have an open circle, I'm not including that negative 2, so that's why it has a parentheses. But on the right side, I am including the 2, so that's why it has a bracket. Now, what is the range? Opposite to the x values is the y values. So this range, again, we read it from bottom to up. It's from negative 4, including negative 4, all the way up to positive 5. Even though I don't have that 5 on the left, it does exist on the right. So we do put a bracket for the 5 because there is a value that exists at that position. All right, so let's go ahead and evaluate now. So the first one here, it's very easy to evaluate functions graphically, all you have to do is first, let's go to the position of x at -1. That's about right here. So then we go and see where this, at this place in time, it hits our graph then. So if we scroll down, if we go down, we see that there our graph hits and this value is -4. So easy, easy, easy stuff, right? So let's look at the second one. F at 0. My x value is 0. So I go and I see where in the graph is 0 here. And we see here it's at -3. So that would be my y value. My y value is -3. Let's do the next one. X at 1. I'm evaluating the function at 1. If I go to 1, and again, I scroll down where it would hit my graph, I see here it's, again, at -4. All right. And then the last one, X at 2. So I go where 2 is, and I follow it to see where it hits my graph, and I see that my graph is there, my filled circle 5. So at y equals 5. So when my input is 2, my y value is 5. All right, so that's how we evaluate graphs graphically. All right, so let's look at this example. Use the graph of the function to find the domain and range of f of our function. So here, again, we have another piecewise function. It's a graph that has two pieces of two functions. Again, I know that I have um, a, a negative slope piece of a line here, and I have a positive slope piece of a line here. But we're going to evaluate this the same way. For the first one, A, I want to find out x equals 2 on the graph. So um, again, these are my reviews of my domain and range for this graph. Um, so let's look at the values for 2. So I go where 2 is, and my y value, I believe it's on the axis, so it's 0. Okay, I'm thinking it's 0, so there, it's 0. All right, and then let's look at the next one. At x equals 1, our x equals 1, oh, it's also, um, remember, this filled circle means that this point exists, but this open circle means that point doesn't exist. So I only do have one answer, and my answer is again 0. Okay, it's not -2 because at that open circle, I just started there, but I don't want to include that point. It doesn't exist there. How about 3? X equals 3. So again, I go to the position of x3, and then I trace it to find where it is on my graph, and it looks like it's a +2. All right, and then the last one, x equals -1. I'll trace that to see where it hits my graph, and I don't know, I I would say 2, right? 2 or a little bit less than 2, but let's just say 2. Yeah, 2. Okay, so again, this is how we would solve or evaluate functions graphically. Okay, all right. Let's get to some good stuff. Combination of functions. So believe it or not, combination of functions is basically just what we're going to be doing is fundamental operations with functions. And these would be adding, subtracting, multiplying, and dividing functions together. But very, very easy. Okay. So let me see that I have as an example, I have these two functions. I have f of x, which is 3x minus 7, and I have g of x, which is 4 minus x. So let's do the first example of the first basic operation, which is addition of functions. So the syntax that you're going to see on your book and maybe on the computer is this: f plus g of x. That's how we read this. But what I would recommend for you guys when solving these is rewriting these in a different format. Okay. What this really means is just f of x plus g of x. You're just adding these two functions together. And then to evaluate, all I do is substitute what f of x is and what g of x is, and that makes my life very, very easy. So let's go ahead and do that. So let's go ahead and substitute. F of x is 3x minus 7 plus g of x, which is 4 minus x. So to solve or simplify, I'm just going to combine my like terms. 3x minus x is going to give me the 2x. The minus 7 plus 4 is going to give me the minus 3. So the evaluation of f plus g of x is 2x minus 3. Okay, hopefully straightforward stuff. Again, let's look at b. Now let's subtract two functions. The way we read this is f minus g of x, but I want to rewrite it to what it really is telling me to do. It's telling me to subtract function f minus function g. So I will substitute. Now I have to be careful because I have a minus, okay? I have to put a parenthesis here because I'm going to have to distribute this negative sign because I have an expression now and I don't just have a single value. All right, so let's go ahead to simplify. Let's distribute that negative, and that's going to give me minus 4. A negative with a positive is a negative with a negative is a positive, so that gives me plus x. Now I can combine my like terms again. 3x plus x is going to be the 4x, and the minus 7 with a minus 4 is going to give me the minus 11. Okay, so f minus g of x produces 4x minus 11. All right, what about multiplication? Let's multiply, or that's what C is asking us, f times g of x. So just as before, I want to rewrite it to what it wants me to do. It wants me to multiply f of x with g of x. So then, again, just substitute. F of x is 3x minus 7, and I'm going to parentheses because, again, it's an expression. G of x is 4 minus x, parentheses, an expression. So now I'm going to FOIL in order to simplify, right? So I'm going to distribute the 3x to the 4, the 3x to the minus 7, the minus 7 to the 4, the minus 7 to the minus x, and that's going to produce this 12x minus 3x to the second minus 28 plus 7x. And if I can combine like terms, I will, and I can, right? I have two only like terms. I have a 12x and a 7x, which will give me 19x, right? So again, you don't have to do this, but I like to put this, what's it called, in standard form, which is in descending order from my exponents. I have a minus 3x to the second plus 19x minus 28. But you don't have to do this, okay? The computer, as long as you have the values, the terms correctly, it's going to mark it correct, all right? And let's do the last example here, the division. This says f divided by g of x, okay? So I am going to replace it to what it wants me to do. What it really wants me to do is just divide function f with function g. So let's go ahead and substitute. And we have 3x minus 7 over 4 minus x. Now, before we say that we're done, we want to see, can we simplify it? Is there something that we can factor out or take away? And the answer for this is no. There's nothing that I can factor from the first that I can say and that I can equally factor from the bottom and cancel out. So then that is my answer. The answer for the division of f of g of x is just 3x minus 7 over 4 minus x. But we have a little extra piece of a problem. Your homework also is going to ask you for this one. Since we are dealing with a fraction, and it's for us to practice domain, they're going to tell you, what is the domain of this fraction, right? What is the domain of this division? So again, what we want to look at is we never want our denominator to be equal to 0. And if we don't see it, we can set it equal to 0. 4 minus x is equal to 0 and solve for x. And we see that if x is equal to 4, we would get a 0 on the bottom. So the domain for this problem would be all real numbers except for 4. But again, our computer problems are going to ask us to write this in the interval notation. So the interval notation of this would be from negative infinity, oh, I forgot the comma there, from negative infinity to 4, union from 4 to infinity. Yes, and again, they are parentheses because I cannot include the 4. Okay, all right. Um, let's look at a few more examples here. Um, let's look at f of x is x to the second and g of x is 2x minus 5. So I'll go a little quicker because I hopefully you all got it. Nobody's asking me any questions. So let's go through these. Let's do the addition of these two functions. Again, separate them into what they really want me to do my substitution, simplify by combining my like terms. Again, and there's nothing to combine, so that would be my answer, right? The x squared x to the second plus 2x minus 5. How about the subtraction? Again, the same thing. F of x minus g of x, substitute. Now on this one, I have to distribute that negative. So that's going to give me x to the second minus 2x plus 5. All right. Again, there's nothing to combine. I have no like terms, so that would be my answer. The multiplication, f times g of x. So we have x to the second times 2x minus 5, distribute dx to the second. So I am going to get 2x cubed, or 2x to the third power. And x to the second times a minus 5 is just going to give me a minus 5 to the second power, right? All right. And again, I cannot combine. There's only two terms that are not like, so that would be my answer. And then the last one. The last one we have f divided by g of x. Okay, so let's divide x to the second divided by 2x minus 5. Again, we want to simplify if we can. So is there something that we can factor from the numerator that would cancel out with a factor from the denominator? So the answer would be no. There's nothing that I can factor from the top or from the bottom. So then that would be my answer. Just x to the second over 2x minus 5. And again, the homework is going to ask us to find the domain. Again, if we don't see it, we never want our denominator, because we're dealing with a fraction. We want our denominator to be equal to 0. So we set 2x minus 5 equal to 0, and we discovered that if x would be equal to 5 over 2, we would get 0, right? So that is our restriction on our domain. We can put all real numbers except for this value. So in interval notation, we union from 5 over 2 to infinity. Okay? Questions? All right. Um, Ms. Chica, would you want to jump in, or I can continue if you like?
Sure, thank you, Ruben.
Oh, my pleasure.
Okay, so let's do one more example. So we have f of x equals x squared plus 3, and g of x is equal to the square root of 2 minus x. So we want to add, as Mr. Carizales says, we want to rewrite this so that it's a little bit easier to read. So we have f of x plus g of x, and we can substitute those values. And so we end up with x squared plus 3 plus square root of 2 minus x. And then we want to see if we can combine any terms. And in this example, we can't. So I like to rewrite it in this form. But again, as Mr. Carizales mentioned, if you left it in this form, that would be okay. So here I can't combine anything else. So my answer is x squared plus square root of 2 minus x plus 3. And if we subtract, we get f of x minus g of x. And here we're going to distribute the negative into the parentheses here. And we end up with x squared plus 3 minus the square root of 2 minus x. And so my answer, my final answer is going to be this, since I can't combine any terms. If we multiply f of x times g of x, again, we can multiply our f of x is x squared plus 3. Our g of x is square root of 2 minus x. So we could, on WebAssign, if I believe if you leave the answer like this, it's going to be counted okay. But you could still simplify a little bit further if you need to. We could multiply x squared times square root of 2 minus x, and 3 times square root of 2 minus x. So your answer would be just x squared times square root of 2 minus x plus 3 times square root of 2 minus x. For division, if we divide them, then we have x squared plus 3 and the square root of 2 minus x. I can't simplify further. And so the last thing to do here would be to find the domain. Since I have a fraction and I also have a square root, I have to worry about both situations. So let's look at the fraction first. If we have the square root of 2 minus x is equal to 0, and if I want to solve for x, I could square both sides. The square root and the square is going to become a 1. So we end up with 2 minus x, and then 0 squared is 0. So in this case, we cannot have x equal to 2, because if I plug in a 2 here, 2 minus 2 would be 0, and the square root of 0 would be 0, which I would have a 0 in our denominator. And so that's not going to be possible. It's undefined. And then for the square root part, we know that the radicand 2 minus x has to be greater than or equal to 0. So I can subtract 2, or I'm going to subtract the x here, right? So if I add x on both sides, I get 2 is greater than x. And so here, there's an error here, right? So if I put the 2 in here, then that's okay. If x is, oh, let me just check here. Hold on. Okay. So if we look at our domain, we have to take into consideration both of these things, right? And so here we're going to end up with negative infinity. And then let's check here. So if I was to use a 3 for x, we would have a negative answer. So x cannot be a positive 3. So our x values are going to have to be less than or equal to 2. And so we're going to have a parentheses because in the fraction part, we cannot use that x equals 2. Excuse me. So the next part of this session is composite functions. And so for composite functions, we're going to have a new symbol, which looks like this open circle. And the way we read this is f composed of g, or some say like g of f of x. And so you're given two functions. And so let's look at the first one. So f and then the little circle and g, we read it as f of g of x. And this second function here is always going to be on the inside. So if we had three functions, let's say if I had an h, the h would always be on the inside, and then the g would be next, and then the f. And so here we have f of g of x. And really what you want to do is, once you rewrite it in this form, we want to ask ourselves, what is g of x? And so if you can see here, g of x is equal to x minus 3. So I'm going to substitute that into the parentheses. And now I'm going to evaluate my function f at x minus 3. So what that means is I'm going to take my x minus 3 here, and I'm going to go to the function f, and wherever I see an x, I'm going to replace that with x minus 3. Okay, so let's go ahead and do that. So here's an x. I'm going to replace it with x minus 3, and then I get the plus 4. So if we simplify, we end up with negative 3 plus 4 is 1. So the composition of f composed with g is x plus 1. Let's try b. Okay, so here we have g of f. So notice again, the function f is going to be the inside function. So let's go ahead and replace f of x with x plus 4. And now I have g of x plus 4. So whatever is in the parentheses here, it's asking me to evaluate it for the function g. So I'm going to go to my function g, and wherever I see an x, I'm going to replace it with x plus 4. So we get x plus 4 and then minus 3, and we end up with x plus 1. So in this situation, f composed of g and g composed of f resulted in the same answer. That was just a coincidence. It doesn't happen all the time. Okay, let's look at the third one. So g composed of g, the second function here is what's in the parentheses. So we're going to substitute g of x into the parentheses here. And then whatever is inside the parentheses, I'm going to replace it into the x. And I'm still dealing with the function g. So I end up with x minus 3 minus 3. And if we simplify, negative 3 minus 3 is negative 6. So we end up with x minus 6. Okay, let's try a different one. So here f of x is x squared and g of x is x minus 2. So we have f composed of g. So again, g is going to be my inside parentheses. I'm going to substitute g of x with x minus 2. And then I'm going to evaluate the function f at x minus 2. So I'm going to replace my x here with x minus 2. And so I get x minus 2 squared. We want to simplify further. So x minus 2 is the same as x minus 2 times x minus 2. So if we multiply this out, we get x times negative 2, negative 2 times x, and negative 2 times negative 2, which is 4, combined like terms. So negative 2x and negative 2x is negative 4x. So my final answer is x squared minus 4x plus 4. If we reverse sum g of f, then again f of x is on the inside. and we're going to replace that with x squared. And now I'm going to evaluate the function g at x squared. So here for my x, I'm going to replace that with x squared, and I end up with x squared minus 2. There's nothing for me to combine, so my answer is x squared minus 2. And the last one, g composed of g, we're going to replace g of x with x minus 2. So if I take this information, plug it in for x, then we end up with x minus 2 minus 2. Minus 2 minus 2 is negative 4. So my final answer is the composition of g is going to be x minus 4. Okay, so let's try another one with the square root. So for letter A, they want us to find f of g. So I'm going to replace my g of x with x squared. And then my x squared, I want to replace it, replace all the x's in the function f with x squared. So I'm going to go ahead and substitute that in for x. So I get the square root of x squared plus 4. I can simplify further. So this is going to be our answer. And then the next one is g composed of f. So if I replace f of x with the square root, now I'm going to substitute square root of x plus 4 into my x here for g of x. And so I get square root of x plus 4 squared. So the square root and the square, earlier I mentioned it becomes 1. Some people like to say that it cancels, but in reality it becomes 1. So we get x plus 4. And so that is going to be our compositions. I can't do anything else there, so my answer is x plus 4. And then letter C wants us to find the domain. So for f of x, we have a square root. That means we have some restrictions. So we're going to take the radicand, which is the inside of the square root, x plus 4, and we're going to set it to greater than or equal to 0. So if I subtract 4, I get x is greater than negative 4. So my domain is going to be from negative 4 to infinity. And now let's look at g. So g of x is x squared. I don't have a fraction. I don't have a square root, and I don't have logarithms. So that means that my domain is negative infinity to positive infinity. So letter C in this problem wanted to get the domain of your composition. So here we got our answer, f composed of g of the square root of x squared plus 4, and we want to find the domain of this composition. In order to find the domain, it's a 3-step process. Step 1, you want to find the domain of your composition. In other words, the domain of your answer. And so here I'm going to take my radicand, x squared plus 4, and set it greater than or equal to 0. But notice that x squared is, or the x is squared. That means no matter what number you put in here, whether it's a negative, your answer is always going to be positive. And so my domain here is going to be from negative infinity to positive infinity. Okay, so now we go to step 2. For step 2, you're going to take the domain of the second, or in other words, the inside function of f of g. So g here is my second function. So you want to take the domain of g, which we already did up here. So the domain of g was negative infinity to positive infinity. And then step 3 is to take what is common to step 1 and step 2. In other words, their intersection. So we're going to take the common thing here. Well, if we have negative infinity to positive infinity and negative infinity to positive infinity, then they have everything in common. So that would be our answer. Okay, so negative infinity to positive infinity. So in this case, sometimes I see people find the domain for this. And so they might have said, well, this is positive, so the domain's going to be negative infinity to positive infinity. But they don't do step 2. And then in this situation, you would have still been correct. But in the situation that we're going to see in a little bit, your answer would not be correct. Okay, so let's look at letter B. So for B, it's G composed of F. Our composition was X plus 4. So our domain, we would say for this, there's no lines, there's no fractions. I'm sorry, there's no fractions, there's no square roots, there's no logarithms. So our domain is negative infinity to positive infinity for my composition here. If you put that as your answer, then you're going to see that it's incorrect. And here's the reason. So to find the domain of the composition, you have to consider these three steps. So the next step here is consider the domain of the inside function. So if we have G composed of F, we're considering the domain of F. So the domain of F, we worked it out up here earlier. So I wrote it down here again. So we would have that the domain is from -4 to infinity. So your domain for the whole composition is what step 1 and step 2 have in common. So this one's from negative infinity to positive infinity. And then this one's from -4 to infinity. So what do they have in common? They only have in common from -4 to infinity. So if here's a number line, here's 0, right? So the first one is everything here, but the second one was from -4. So here's -4 all the way over here. So what they have in common is just going to be this part, okay? So that's going to be your answer for the composition of G of F. So your domain would be -4 to infinity. So let's try another one. Let's do F composed of G first. And so here I'm going to rewrite this as F of G of X. I'm going to replace G of X with X plus 2. And then I'm going to take this information and plug it in for X in the function F. And so I get 1 divided by X plus 2. So that's my composition. And then for letter B, we have G of F. So F of X is on the inside. We're going to replace that with 1 over X. And then I'm going to take 1 over X and go to the function G. Wherever I see an X, I'm going to replace it with 1 over X. So I have 1 divided by X plus 2. So that's my composition for G of F. So now we can find the domain. Let's find the domain of each function. So for F of X, I have a fraction. So here we can see that X cannot be 0. So my domain goes from negative infinity to 0, union 0 to infinity. And notice we use parentheses because we don't want to include 0. And then G of X is, this is a line. There's no fractions, no square roots, and no logarithms. So the domain is negative infinity to positive infinity. So now to find the domain of the whole composition here, step 1, what is the domain of your answer that we got for the composition? So if we take the denominator here, set it equal to 0, we get X is equal to -2. So my domain for that is negative infinity to -2, union -2 to infinity. Step 2, we want to consider the domain of G, YG, because that is our second function that we have. And so for G, we figured out was negative infinity to positive infinity. So I'm going to write it here. And then to find the final domain of your composition, you want to take what they have in common from here to here. So they have everything in common, right? Except for what? For that 2. So we can, so our domain is going to be everything except that -2. And this -2 would cause us to have an undefined answer if we were to plug it in. Okay, let's try letter B. So for letter B, the domain of the composition is going to be everything except for 0. So we can write it as we did here. And then we're going to consider the domain of F. The domain of F is this right here. Okay, so step 3, then our domain of G of F is going to be from negative infinity to 0, union 0 to infinity. All right, so now we have find two functions, f and g, such that when you take the composition, we're going to get h of x. And h of x, Albert, Mr. Isasi?
Yes, Yvette, I did a mistake even on the PowerPoint. It's supposed to be G of F instead of F of G.
Oh, for this one?
Yes, ma'am.
Okay, so let me change it here.
Yeah, it's supposed to be G of F.
So you're talking about here, right?
Yes, ma'am. Yes, G of F. Yes, because this will be the inside.
Okay.
Okay, now, yeah, that was a mistake.
All right. Thank you, Mr. Isasi.
Oh, you're welcome.
Okay, so let me put a. Okay. So what they're trying to do here in this problem is they're giving us our composition. In other words, if I go back to this slide, they're giving you this information here, and they want you to find two equations that when you do the composition, you get this result. So over here, they want you to find what is f of x and what is g of x so that you get this result right here. Okay. So one kind of easy way to look at this is you can pick two things here. F of x could be what's in the parentheses, and g of x can be what is outside of the parentheses. And so here, if we plug in g of x is the outside of the parentheses. So inside of the parentheses, we have 3x plus 9. So I'm going to let that be f of x. And then outside of the parentheses is the square. Well, instead of writing 3x plus 9, we can represent that with just an x, right? And then if you're not sure if the answer is correct, then we can actually do the work, right? So if I was to have f composed of f, am I going to get this answer? So if you do the work, is this the answer we're going to get? And we will, right? So um, for example, let me just do it. I think we have 8 minutes left, so we have some time. So let's say if we did G composed of F, okay, then we would have, oops, G of F of X, which we said 3X plus 9. And then now we're going to take this 3X plus 9 and substitute it in for our X in the G function in here. So we get 3X plus 9 squared. And so this result is the result that we had from the beginning, which is this one here. Okay, so I think we have one more example here. Okay, so we have these two things. So we want to find two functions, right? So now, notice, oops, I think I almost got out. Okay, so notice here, this is what they want us to find. So what is going to be your inside function and what is going to be your outside function? So I'm going to give you a couple of seconds to try to see if you can decide which one goes where. Okay, so if you have a possible solution for what f of x might be or what g of x might be, throw it in the chat and we can see if we one of us will get the correct answer. Okay, so I'll give you 30 seconds. So you want to think about this problem here. Is there something that's inside, something that's outside? Any volunteers to give it a shot? Let me see. I think. Okay, Mr. Carizales says he knows. Should we give him a shot? Miss Patricia also says that she has square root of x question mark. Okay, for f of x. Okay, well we can try that. Let's just try it. All right. So Miss Patricia is saying, let's try square root of x for f of x. Okay. So what will we try for g of x? What is the inside of g of x? So the only thing left in there is 2 minus x. Okay, so this is what we mean by the inside, right? So this is the inside. And then the square root is actually what we're calling the outside. So let's check if this is correct. Well, if we did f composed of g, then that's f of g of x. So we end up with f, and then g of x is 2 minus x. So anywhere I see an x, I'm going to substitute that in there. And so here's my x. So I get square root of 2 minus x. So my answer here is what I had at the beginning. And so Miss Patricia, you were correct. And so if I click the slides, then we'll see that, right? And all right, sounds good. So maybe I shouldn't have spent too much time there because we had a couple of more slides. But another thing you're gonna see, I believe in 1.5, if you're in 1314, 1324 might not see this. So I'm gonna go ahead and throw it in here is, you wanna know when the function is increasing, decreasing, or constant. So we read the graph from left to right. And so if we're going left to right, this function is decreasing here, okay? And we wanna know at what interval. And so since it has an arrow here, that means that it's gonna be decreasing from in negative infinity all the way till we get to 6. And if I go down here, we can see that at 6, it starts to change. So my interval is going to go from negative infinity all the way to 6. And then what happens? Once we reach 6, then we can see that the graph starts to increase again. And at what interval does it increase? It's going to increase from 6 all the way to infinity. Okay, so my answers here would be increasing from 6 to infinity, decreasing from negative infinity to 6, and there's no constant part, so we say does not exist. Okay, let's try one more, and then I think that's the last. On WebAssign, they don't put the arrows here, but these, if you don't see that, these are going to infinity here. Okay, so let's check. So my graph here, if we're going from left to right, the graph is decreasing, right? And then if we're going from left to right here, the graph is increasing. But we need to determine the interval. So it's going to be decreasing from negative infinity, all these numbers right here, until it gets to negative 5. So we say negative infinity to negative 5. And then it's going to start increasing from 5 to infinity. So one of the common mistakes I see in this section is students try to use the y values, okay? But here we're just interested in the intervals when it occurs. So we're looking at the x-axis, okay? So again, from 5 to infinity. And I believe that was the last slide. If you're interested in downloading this PowerPoint, you can. If you see my blue arrow here, right on top of my blue arrow, there's a box with an arrow pointing down. If you click on that arrow, it's going to allow you to download the PowerPoint. And then also in the announcements, um, I believe they put the YouTube link so that you can watch this whole presentation again in case you start doing the homework for these sections and want to see some examples, then you'll see that here. Now next week, we'll be covering factoring, and factoring plays a crucial role in especially in chapter 2 for 1314, and for 1324 I'm not sure what section that is. And Mr. Isasi is going to be going over the different ways of factoring, which is going to help us to find the solutions to um, quadratic equations, or even equations that are cubic. Okay, so try to come to that session because it's going to prepare you. It's going to give you the tools you need so that you're ready for chapter 2. Okay, if you have any questions, let us know. We're going to stay here for a few minutes, and we thank you for coming. Stay warm, and I'm going to pass it over to our wonderful staff.